In this video, we are going to learn about the laws of exponents. So let us consider the first law. Now the first law is the product law. Now, according to the product law, a to the power of m times a to the power of n is equal to a to the power of m plus n. So here we have the product law. And this tells us information about the product a to the power m times a to the power n. So let us consider an example. Let us consider 4 to the power 2 times 4 to the power 3. Using the product law, this will be equal to 4 to the power of 2 plus 3. Here we can see that a is 4. And the value of m is 2, and the value of n is 3. So if we calculate this, we end up with 4 to the power of 5. Now let us have a look at why the product law works. Let us consider this example. So we have 4 to the power of 2 times 4 to the power of 3. Now, what is 4 to the power of 2? That means 4 multiplied by itself a total of 2 times. And with this, we multiply 4 to the power of 3. And that is just 4 multiplied by itself a total of 3 times. So we can see that this is 4 multiplied by itself a total of 5 times. And so we end up with 4 to the power of 5. And we can see that we end up with the same answer. So this is why the product law works. Now there are a few things that we need to remember here. The first thing we need to remember is that we do not multiply the bases. So 4 to the power of 2 times 4 to the power of 3 is not equal to 4 times 4, which is 16, to the power of 2 plus 3, which is 5. This is not correct. We do not multiply the bases. That is, the base will remain the same. So we end up with the base 4. And so the correct answer is 4 to the power of 5. We do not multiply the bases. Also, note that we must have the same base. So we have to have the same base, something like this, where both of the numbers have the same base of 4. So that means we cannot apply this product law to something like 2 to the power of 4 times 5 to the power of 7. And that is because the bases are different. Here the base is 2, and here the base is 5. The bases are different, and so we cannot apply the product law to a product like this. Now consider the next law, and that is the quotient law. Now, according to the quotient law, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So this is the quotient law. And it tells us about the quotient a to the power of m divided by a to the power of n. So let us consider an example. Let us consider 4 to the power of 5 divided by 4 to the power of 2. Now using the quotient law, this will be equal to 4 to the power of 5 minus 2. Here we can see that the value of a is 4. The value of m is 5. And the value of n is 2. So we have 4 to the power of 5 minus 2, and that is equal to 4 to the power of 3. Now, let us see why exactly this works. So we have 4 to the power of 5. That is 4 multiplied by itself a total of 5 times. And we divide that by 4 to the power of 2. Now that means 4 multiplied by itself a total of 2 times. Now we can cancel out these 4's, and we are just left with 4 multiplied by itself 3 times, and that means 4 to the power of 3. So we can see that we end up with the same answer, and this is why the quotient law works. Now there are a few things that we need to remember. The first thing is that we should not divide the bases when we use the quotient law. So 4 to the power of 5 divided by 4 to the power of 2 is not 4 by 4, which is 1 to the power of 5 minus 2, which is 3. The correct answer is 4 to the power of 3. We do not divide the bases. Another thing we need to remember is that we need to have the same base if we want to use the quotient law. For example, over here we have the same base of 4. So we cannot apply the quotient law to something like 5 to the power of 6 divided by 3 to the power of 4. And this is because the base over here is 5 and the base over here is 3. So we can see that the bases are different, and so we cannot apply the quotient law to this. Let's move on to the next law, and that is the power of a power law. According to this law, a to the power of m whole to the power of n, this is equal to a to the power of m times n. So this is the power of a power law, and this describes the result of taking the power of a power. So let us consider an example. Let us consider 7 to the power 2 whole to the power of 3. Using this law, this will be equal to 7 to the power of 2 times 3. Here we can see that the value of a is 7, the value of m is 2, and the value of n can be seen to be 3. So we have 7 to the power of 2 times 3, and that is 7 to the power of 6. So this is our result. Now let us have a look at why this works. So we have 7 to the power of 2. That is 7 multiplied by itself 2 times. And we raise this to the power of 3. So this means we have 7 times 7 multiplied by itself 3 times. So we have 7 times 7, multiply that again by 7 times 7, multiply that by 7 times 7. So we can see that we have multiplied 7 times 7 by itself 3 times. And if we do that, we end up with 7 multiplied by itself 6 times, and so this is 7 to the power of 6. And we can see that we have the same answer, and so this is why the power of a power law works. Next law is the power of a product law. Now, according to this law, a times b whole to the power of m is equal to a to the power of m times b to the power of m. Now this is the power of a product law, and it tells us what happens when we have the power of a product. Now let us consider an example. Let us consider 8 times 6 whole to the power of 3. Using the power of a product law, this is equal to 8 to the power of 3 times 6 to the power of 3. Here we can see that the value of a is 8. The value of b is 6. And the value of m is 3. So this is the result that we get. Now let us see why this law works. So we have 8 times 6 whole to the power of 3. So that means we have 8 times 6 multiplied by itself 3 times. So we multiply this by 8 times 6. We multiply it again by 8 times 6. Now we can use the commutative law of multiplication to rearrange this product so that we end up with 8 times 8 times 8 times 6 times 6 times 6. So we have 8 multiplied by itself 3 times. So we end up with 8 to the power of 3. And we multiply that with 6 multiplied by itself 3 times. So that's 6 to the power of 3. So we end up with 8 to the power of 3 times 6 to the power of 3, and that's exactly what we got previously. And so this is why the power of a product law works. Next law is the power of a quotient law. Now, according to this law, A divided by B whole to the power of M is equal to A to the power of M divided by B to the power of M. Now, this is the power of a quotient law, and it tells us what happens when we have the power of a quotient. Now, let us consider an example. Let us consider 2 divided by 11 whole to the power of 4. Now, using the power of a quotient law, this will be 2 to the power of 4 divided by 11 to the power of 4. Here we can see that the value of A is 2, the value of B is 11, and the value of M can be seen to be 4. So this is what we get. Now let us see why exactly this law works. So we have 2 divided by 11 to the power of 4. That means 2 by 11 is multiplied by itself 4 times. So we have 2 by 11 times 2 by 11 times 2 by 11 times 2 by 11. Now, using the definition of the multiplication of fractions, this will be equal to 2 times 2 times 2 times 2 divided by 11 times 11 times 11 times 11. That is, we multiply the numerators together and we multiply the denominators together. So in the numerator, we can see that we have 2 multiplied by itself 4 times, so it is 2 to the power of 4. And in the denominator, we have 11 multiplied by itself 4 times, so we have 11 to the power of 4. So the answer is 2 to the power of 4 divided by 11 to the power of 4, and that is exactly what we got over here. So we can see that we have the same answer, and this is why the power of a quotient law works. The next law is the zero exponent law. Now, according to this law, if we have a real number a which is not equal to 0, that is, if we have a non-zero real number a, then a to the power of 0 will always be equal to 1. So this is the zero exponent law, and it tells us what happens when the exponent is 0. So let us consider a few examples. Let us consider 1 to the power of 0. Here we can see that a is 1, and so it is non-zero, and hence 1 to the power of 0 will be equal to 1. Next, let us consider 5 divided by 7 whole to the power of 0. Here we can see that the value of a is 5 divided by 7, that is non-zero, so 5 by 7 to the power of 0 is 1. Next, let us consider pi to the power of 0. Here we can see that the value of a is pi, and that is non-zero, so pi to the power of 0 will be equal to 1. So now let us consider why the zero exponent law works. So let us consider any non-zero real number a, and let us raise that to the power of m. And let us consider m to be some non-zero real number. So if we consider that, since a is not equal to 0, so we can say that a to the power of m will also be not equal to 0. And because of that, we can divide a to the power of m by a to the power of m. And if we divide any non-zero real number by itself, we will get 1. Now, on the left-hand side, we can use the quotient law of exponents. And according to that, a to the power of m divided by a to the power of m will be equal to a to the power of m minus m. So this is equal to 1. So we have a to the power of m minus m, and m minus m is 0, and this is equal to 1. Hence, we have shown that a to the power of 0 will be equal to 1. And this is why the zero exponent law works. The next law is the negative exponent law. Now, according to this, if we have a real number a, which is not equal to 0, and we have a real number n, which is also not equal to 0, then a to the power of negative n is equal to 1 divided by a to the power of n. So this is the negative exponent law, and it tells us what to do when we have a negative exponent. So let us consider a few examples. Let us consider 2 to the power of negative 3. This will simply be 1 divided by 2 to the power of 3. Here we can see that the value of a is equal to 2, and we can see that the value of n is equal to 3. Now let us see why exactly the negative exponent law works. Let us consider a to the power of negative n, where a and n are non-zero real numbers. Now we can write the exponent negative n as 0 minus of n. This is because 0 minus n is equal to negative n. Now, using the quotient law, a to the power of 0 minus n will be equal to a to the power of 0 divided by a to the power of n. Using the zero exponent law, a to the power of 0 will be 1. So we end up with 1 divided by a to the power of n. So we can see that a to the power of negative n is equal to 1 divided by a to the power of n. And so we can see that the negative exponent law has been proved. Now let us think about this intuitively. A to the power of negative n should mean that we have to multiply a by itself negative n number of times. But this doesn't make any sense, because how can we multiply a number a negative number of times? So instead of this, let us think about it in a different way. Now, if we consider the numbers n and negative n, then negative n is the opposite or the additive inverse of n. Now, division is the inverse operation of multiplication. So a to the power of negative n actually means that we need to divide by a n times. And because of that, a to the power of negative n is equal to 1 divided by a divided by a divided by a, and so on until we divide by a n times. So we end up with 1 divided by a times a, and we multiply a by itself n times, which means that in the denominator we get a to the power of n. And so we can see that we have obtained that a to the power of negative n is equal to 1 divided by a to the power of n. Now let us consider a few practice problems. Now the first problem is 4 to the power of 3 times 4 to the power of negative 2 times 4 to the power of 5. Now to calculate this, we can use the product law. Now using the product law, this will be equal to 4 to the power of 3 plus negative 2 plus 5. Or simply, we can write that as 4 to the power of 3 minus 2 plus 5. Now 3 minus 2 plus 5 is equal to 6. So the final answer is 4 to the power of 6. Next, we have 5 to the power of 0. Now, using the zero exponent law, 5 to the power of 0 will be 1. Next, we have negative 5 to the power of 0. So this means negative of 5 to the power of 0. And 5 to the power of 0 will be 1 using the zero exponent law, so we end up with negative 1. Next, we have negative 5 whole to the power of 0. So using the zero exponent law, this will simply be equal to 1 because we have a non-zero number raised to the power of 0. Then we have negative of negative 5 whole to the power of 0. So we have negative of negative 5 whole to the power of 0. And using the zero exponent law, that is 1. So the final answer is negative 1. Now let us move on to the next problem. We have 2m to the power of 2 times m to the power of 3 divided by m times s to the power of 3, and the entire thing is raised to the power of 4. So let us work on the expression inside the parentheses. So first of all, let us leave the denominator alone, and let us work on this, m to the power of 2 times m to the power of 3. Since the base is the same, that is, the base is m for both of these terms, we can use the product law. And using that, m to the power of 2 times m to the power of 3 will be equal to m to the power of 2 plus 3. So we end up with 2 times m to the power of 5, and we divide that by m times s to the power of 3, and we raise this to the power of 4. We can use the quotient law because we have m to the power of 5 and m over here. Now, m can just be written as m to the power of 1. So we can use the quotient law, and m to the power of 5 divided by m to the power of 1 is simply m to the power of 5 minus 1. And we are left with s to the power of 3 in the denominator. So what we get is 2 times m to the power of 4 divided by s to the power of 3, and we raise this to the power of 4. Now we can use the power of a quotient law. And according to that, this will be 2 times m to the power of 4 whole to the power of 4 divided by s cubed to the power of 4. Now in the numerator, we can now use the power of a product law. And using that, this will be 2 to the power of 4 times m to the power of 4 whole to the power of 4. And we leave the denominator as is. Now, 2 to the power of 4, that is just 2 multiplied by itself 4 times. Then we have m to the power of 4 whole to the power of 4. We can use the power of a power law, and using that, this will be m to the power of 4 times 4. Similarly, in the denominator, we can use the power of a power law, and we will end up with s to the power of 3 times 4. So 2 times 2 times 2 times 2, that will be 16. Then we have m to the power of 4 times 4, that is 16. And we have s to the power of 3 times 4, that is 12. So our final answer is 16 times m to the power of 16 divided by s to the power of 12. Thank you for watching this video. I hope you enjoyed it. Don't forget to comment, like, and subscribe. See you next time.